Yes, students, so in the continuation of carbamates compounds, today's topic is esterification. 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 What is ester and what is esterification? See the ester functional group. Ester functional group means C double bond O functional group which contains C, then C. C double bond O functional group, left hand side carbon containing alkyl group, right hand side also another alkyl group will be present. Such type of the functional group is called as a ester. C double bond O, then here alkyl group, then one more alkyl group, left and right side of that group. So then that is known as the ester functional group. Ester functional group. Let us see CH3, C double bond O, CH3. With respect to the C double bond O, left side methyl group is there, right side also methyl group is present. Then C2H5, C double bond O, CH3. Left side methyl group, right side methyl group. C2H5, C double bond O, C2H5. Left side ethyl group, right side ethyl group. CH3 group is called as methyl. C2H5 functional group, the C2H5 alkyl group is known as ethyl. C3H7 is called as propyl. From alkane, removal of a nitrogen. When hydrogen is removed, the obtained species is called as alkyl group. Alkane. From alkane, when hydrogen is removed, then whatever the species is obtained, that species is called as a alkyl group. So from CH4, you will get the methyl. From ethane, C2H6, you can get the ethyl. From C3H8, propane, after removal of hydrogen, propyl is obtained. Okay, so that's why ester functional group is nothing but with respect to the C double bond O, left side alkyl group and right side also another alkyl group is present, same or different. Such kind of the functional group is known as the ester functional group. Then what is esterification? Esterification is nothing but the reaction of carboxylic acid. The reaction of carboxylic acid or acid chloride with alcohol in presence of mineral acid. Mineral acid gives esters. This is called as esterification. What is esterification? The reaction of carboxylic acid or acid chloride. Carboxylic acid or acid chloride with alcohol in presence of mineral acid. Mineral acid means H2SO4. Okay, HCl, which will give H plus ions. So in mineral acid gives esters. That is called as a esterification. See here I am taking the RCOOH, carboxylic acid, with alcohol, R prime OH. Both are not same. That's why I am taking R prime. You can also take same alkyl groups. R is nothing but alkyl group. R is nothing but the alkyl group. What is that alkyl group? This one. If instead of R, if you take CH3, methyl. Instead of R, if you take C2H5, ethyl. Instead of R, if you take C3H7, propyl. So that is a alkyl group. So RCOH plus R prime means both two alkyl groups are not same. They are different. That's why I am using the prime. RCOH plus ROH in presence of H2SO4. Then what happens? From one carboxylic acid OH group is removed, another alcohol hydrogen is removed. OH is eliminated as a water molecule. Then what you can get? R. CO. CO means we can take as C double bond O. Next O R prime. O R prime plus water. Water. See, R C double bond O R prime is the ester. That is the ester functional group. Now let us see. This is the first example. Now instead of R I am taking CH3 COOH. CH3 COOH, acetic acid plus alcohol C2H5OH. CH3 COOH plus C2H5OH in presence of H2SO4. In presence of H2SO4. So from here the OH is removed. Then from alcohol hydrogen is removed as water molecule. Then obtained product is CH3 C double bond O C2H5 plus water H2O. This is known as ethyl acetate. Ethyl acetate. Ethyl acetate. See the first example. RCOH is carboxylic acid. R is generally alkyl group. What are the alkyl groups? So all these are the alkyl groups. R group. R group. You can take methyl, you can take ethyl, you can take propyl. So RCOH plus R1OH. So COH, OH is eliminated. From R1OH, H is eliminated. OH, H is eliminated as a water molecule. Then it gives R C double bond O R prime plus H2O. Second one. R means CH3. CH3 COOH plus R prime C2H5OH ethyl alcohol in presence of H2SO4 gives CH3 C double bond O C2H5 plus water OH then H. H is the H2O. CH3 C double bond O C2H5. That is called as the ethyl acetate. Second example. Here I am taking R C double bond O Cl acid chloride plus alcohol R1OH same in presence of H2SO4. Here Cl then hydrogen, both two are eliminated and it gives R C double bond O R prime plus water. This is ester. R C double bond O R prime is the ester. Instead of R I am taking CH3. CH3 C double bond O Cl plus R1OH C2H5OH. C2H5OH. Then here HCl, here not H2O. HCl. 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 Here Cl then hydrogen. Here also same. HCl is eliminated and it gives CH3 C double bond O C2H5 plus HCl. This is ethyl acetate. CH3 C double bond O Cl plus C2H5OH. Loss of HCl takes place to give the ethyl acetate. That is also called as ethyl acetate. See how the esters are prepared. The reaction of carboxylic acid with alcohol in presence of mineral acid will give ester. That is one method. The second method is the reaction of acid chloride. What is that acid chloride? RC double bond O Cl is acid chloride. Acid chloride reacts with alcohol in presence of H2SO4 gives esters. That gives esters. RC double bond O Cl plus R1OH in presence of H2SO4. Loss of HCl will produce the ester. That is also called as the esterification. Esterification. Esterification is nothing but the reaction of carboxylic acid or acid chloride. Acid chloride is nothing but RC double bond Cl. The CH3 C double bond Cl is called as the acetyl chloride. Acetyl chloride. Acetyl chloride. So the reaction of carboxylic acid or acid chloride with alcohol in presence of mineral acid gives esters. This is known as the esterification. That is called as the esterification reaction. So in laboratory also, by doing an experiment, so we can easily identify this esterification reaction. How means, first you take a tripod stand and keep a water bath on it. So then under this we have to use the burner, okay, burner. So then, so in this water bath, so we have to pour some water and slightly heat it. What we are taking? Initially we are taking a tripod stand. Then on that tripod stand, so we have to place one water bath. Next, so under the tripod stand we have to take the Bunsen burner. So burner. So then pour the water in water bath. This is water bath. So that contains water H2O. Then heat it. Now you take one boiling tube. This is called as a boiling tube. In that boiling tube, you have to take carboxylic acid, any one carboxylic acid, and add alcohol solution. This is carboxylic acid. Alcohol is nothing but the ethanol carboxylic acid. Then add alcohol. Then with the help of the holder, this is the holder. With the help of the holder, just you hold it and keep this boiling tube in water bath consisting the water. So slightly again you have to heat it for 5 to 10 minutes. Before heating the boiling tube, you have to add some volume of H2SO4 solution. Little bit amount of H2SO4 solution. So here I am taking, let us assume here I am taking 3 ml of carboxylic acid, 3 ml of alcohol, then we have to add at least 2 ml of H2SO4. By adding carboxylic acid, then alcohol to the mixture, by adding the H2SO4 solution, then hold that holder and keep it in water bath. So then heat it. Then what happens? Due to that heating, carboxylic acid reacts with alcohol. Carboxylic acid reacts with alcohol in presence of H2SO4 and that gives fruity smell. Suppose fruity smell is observed, that indicates the formation of the esters. If there is no fruity smell, there is no formation of esters. How can you identify this? With respect to the smell, with respect to the odor, we can easily identify this esterification reaction. So initially we are taking the tripod stand, then water bath. In that we have to fill the water bath with water. So then heat it under the Bunsen burner. Then separately you take one boiling tube. In that fill that boiling tube with the carboxylic acid, then alcohol, then add the acid. Carboxylic acid, alcohol, then add acid. With the help of holder, just you hold it and keep it in water bath and heat it for 5 to 10 minutes. So after heating, what happens? You will observe the fruity smell. If fruity smell is observed, definitely so the formation of ester can be confirmed. If there is no fruity smell, no formation of esters. This is the lab activity. In the lab, we can do this experiment to identify the esters. Okay, this is about the esterification. Once again, you see what is esters? C double bond O functional group consisting alkyl groups or aryl groups also. For your 10th class, we have the alkyl groups. So that is called as an ester. These are the examples: CH3, C double bond O CH3, C2H5, C double bond O CH3, C2H5, C double bond O C2H5. They are the examples for the esters. Next, what is the esterification? The reaction of carboxylic acid or acid chloride with alcohol in presence of mineral acid gives esters. This is called as the esterification. And see the reaction. General reaction, carboxylic acid, RCOH plus R1OH. In presence of H2SO4 gives ester. So instead of R group, I am taking CH3. CH3COH plus C2H5OH. That gives the ester. Acid chloride, RC double bond O Cl plus R1OH. That gives the RC double bond O R prime. Then CH3 C double bond O Cl plus C2H5OH. That gives CH3, C double bond O, C2H5 plus HCl. So acetyl chloride, acetic acid. This is acetic acid, acetyl chloride. Both two interacts with the alcohol in presence of H2SO4 mineral acid to give the esters. Then lab activity. Okay? Esterification. The next topic. After this esterification, once you see it again, total picture regarding to the esterification. Right? Right. Now, let us see the another topic. Saponification. Saponification. Esterification. Saponification. Both two terms are important. Define esterification and saponification. Saponification. What is saponification? See here, the term saponification is used for the soaps. Soaps. General formula. General formula of soap. General formula of soap is equal to RCOONA. RCOOK. RCOOK. Sodium R, potassium salts of higher fatty acids, higher monocarboxylic acid, that is higher monocarboxylic acids, that is nothing but fatty acid. Higher monocarboxylic acids is called as a soap. What is the soap definition? Sodium or potassium salts of higher monocarboxylic acids are called as soap. This is known as soap. What is the general formula? RCONA, RCOKs. So what are the common fatty acids? One is stearic acid. C17H35COOH, stearic acid. Oleic acid. C17H33COOH, oleic acid. Palmitic acid. Okay. So in that palmitic acid, C15H31COOH. Once you check it properly, see that palmitic acid, stearic acid, oleic acid. Examples: palmitic acid, stearic acid, oleic acid. So these are the fatty acids. One is stearic acid, C17H35COOH, oleic acid, C17H33COOH, palmitic acid, C15H31COOH. These are the common fatty acids. Stearic, oleic, palmitic. Instead of R group, we can take stearic acid or oleic acid or palmitic acid. Then what is the definition for saponification? The alkaline hydrolysis of tristearates. The alkaline hydrolysis of tristearates will give soap. This is called as saponification. This is called as saponification. What is that saponification? The alkaline hydroxys of tristearates, what is ester? The alkaline hydroxys of tristearates will give soap. So soap is known as the process is known as the saponification. The alkaline hydroxys of tristearates will give soap, which is also called as the saponification. This is the information regarding to the saponification. Once again, you see in saponification, so we have to discuss about the soaps. The general formula of soap is RCONA, RCONA or RCOOK, sodium or potassium salts of carboxylic acids. Sodium or potassium salts of carboxylic acids is called as soap. Once again, you see the stearic acid, oleic acid and palmitic acid. Once you check it, the formula. Stearic acid, oleic acid, palmitic acid. C17H35COOH, oleic acid C17H33COOH, palmitic acid C15H31COOH. Stearic acid means C17H35COOH. C17H35COOH. See this saponification. Actually, this reaction is not in your syllabus. It is not given in your textbook also. But let us see. The alkaline hydroxys na. Here I am taking tristearate CH2. So C17O, C double bond O, C17H35. Another CHO, C double bond O, C17H35. CH2 O, C double bond O, C17H35 plus NaOH. This is alkaline hydroxys na. You take H2O or NaOH. NaOH, alkaline hydroxys, that is H2O. So then what happens? That gives, here the cleavage takes place in between these two. So it gives CH2OH, CHOH, CH2OH plus 3 molecules of C17H35 COONA. You take 3 NaOH. CH2OH, CHOH, CH2OH, C17H35 C double bond ONA, C17H C double bond ONA, C17H35 C double bond ONA. This is the soap. So this one is glycerin. What is the structure of glycerin? CH2OH, CHOH, CH2OH, CH2OH, CHOH, CH2OH. Okay, this is the primary information regarding to the soap. That is called as the saponification. Saponification. Okay, what is that saponification? The alkaline hydroxys of tristearates will give the soap. That is called as the saponification. What is the reaction? This is tristearate. Suppose if instead of stearic acid, we can also take the oleic acid, we can also take the palmitic acid. But here I took the stearic acid, C17H35 C double bond CH2, C17H35 C double bond CH, C17H35 C double bond CH2. Then hydroxys, the alkaline hydroxys. It gives CH2OH, CHOH, CH2OH plus C17H35 CONA, C17H35 CONA, C17H35 CONA. That is the soap. Sodium stearate. What is the name of this compound? Sodium stearate. Sodium stearate. Sodium stearate. Once again, you see that formula. See that formula of the stearic acid, oleic acid and palmitic acid. And also check that the saponification reaction. So in examination you may get define the esterification and saponification with suitable examples and with the reaction. So you have to write the reaction. What is esterification? One equation. What is saponification? Equation. Saponification is nothing but we have to take the tristearide and do the alkaline hydrolysis. That forms the glycerin. That is the glycerin. So that's why it is known as the saponification reaction. So tristearates plus NaOH plus water, that is alkaline hydrolysis, will give the glycerin, then soap. Check it properly. Esterification, then saponification. The common acids, that is fatty acids are stearic acid, oleic acid, then palmitic acid. Stearic, oleic and palmitic acid. See that formula carefully. Stearic acid, oleic acid, then palmitic acid.